Hello everyone and welcome to this short video walkthrough on how to adapt your scripts to MockFrost. So basically what I'm going to show you today is I'm going to start with some off-chain scripts that have been developed using the PyCardano framework and the BlockFrost endpoint. So you are probably aware there's the website called blockfrost.io, and they host a great endpoint and API for interacting with the Cardano blockchain through submitting transactions, fetching your UTXOs, and so on. However, this allows you to interact with, for example, pre-production networks or preview networks, like test networks where you can test your transactions. However, the limitation is that you are bound to a publicly hosted network that has to be up online. You need to create a new account for every time you test your contract and so on. And this is not really suitable for unit tests. So if you want to generate unit tests that deterministically reproduce your code, that run through the exact same configuration, maybe even a very complex configuration, where you need to initialize some contracts, mint some tokens, send them from place to place, then MockFrost is basically what you're looking for. So what MockFrost does is maybe you can check the docs for BlockFrost. They look like this. You have a bunch of different endpoints. And what MockFrost gives you is also a bunch of different endpoints. And it tries to simulate the BlockFrost API to the extent that you can basically drop in whatever your script that previously used BlockFrost was written in, whatever language, could be Python, could be Rust, whatever. As long as it uses BlockFrost, you should be able to drop in MockFrost and be able to reliably, deterministically reproduce your basically workflow, your test cases. And then what I'm gonna demonstrate today is we take some code written for BlockFrost in the PyCardano framework. We're going to manually create a MockFrost session, and then we will interact with that session using the MockFrost API instead of the BlockFrost API. So let me quickly demonstrate. We start with the option starter kit, and I've already prepared setting up everything. Usually it would run with Ogmios, but I've adapted the cases to use BlockFrost. And basically what the starter kit already contains is some code that lets you interact with the smart contract on Cardano. So what you have, for example, here is the distribute script. That's not a smart contract yet, but there you can, it lets you take some funds from an address and send it to another address. And in order to set this up, you see I've already tried this a bit. In order to set this up, what you need to do is to create a new contract, a new address. There's some tools here, create key pair, to create some addresses. They will create addresses here. And then you need to go to the faucet for testnets. We'll go here, insert your address, receive your transaction. This will take a few blocks until it's confirmed. Then you have to distribute the funds. For example, here I conveniently already created a script which lets you distribute funds from one address to the other one. This is 20 ADA, so you can run this, and then it will give you a link where you can see the transaction on blockchain. However, as I said, we are waiting for an actual hosted blockchain, so it will take a bit to arrive. Was actually the wrong link. I think we are on the pre-prod network here. So These links should be pre-prod instead. Anyways, it's still not here yet. Still not here. Okay, now finally we can see that it was possible to send the funds from this to this address. So you see, it's quite inconvenient to be running against an actual BlockFrost engine. Now we can further, like this was not actually a smart contract transaction. We still want to run, following the README here, we still want to run MakeQuest to deposit some funds at an address. Now let's look again, we need to correct this link. Okay, it's not in the blockchain, so we cannot continue spending funds yet. Like, we cannot test this contract. If we would try to run it, we would probably get an error because our transaction is not yet on the blockchain. Run it. Yeah, no, it's not there yet, right? So we are waiting. We are stuck waiting here for quite a while. In that time, I will just quickly walk you through the contract. So what are they doing? These are the off-chain scripts, actually. These are taking funds from payment address, add outputs to the beneficiary, and then build and sign the transaction. So you're not actually like manually taking any UTXOs here. The transaction builder takes the context, which is our BlockFrost chain context, just gets all the information from the pre-production network, generates the transaction and submits it. And for the MakeVest, so we have a vesting contract here, which basically checks, this all validator, checks that the person, like some person gets the funds, it has to sign the contract, sign the withdrawal transaction, and also some deadline has to be reached. So only after a specific time we are allowed to withdraw the funds. So in MakeQuest, we are generating this transaction. Take the current time, add some wait time, which here is 0 seconds actually. And then we send the funds from, again, the payment address to the script address. We attach the datum. The datum is the parameters, is who we want to send the funds to and how long they have to wait. And then we submit this. And this submitting was possible, was successful, but still we are waiting for a transaction to show up. Here we go. Okay, 1 minute ago, because I talked a lot with you. So there are now 3 ADA. Here you can see the datum. And now finally we are actually able to run CollectVest. Okay, that was successful, that's great. Yeah, still we have to wait until the transaction is on chain. All right, so far so good. This is basically how it would work when you were using BlockFrost. However, now I want to demonstrate to you how we can instead. So if you look at this, basically it's all very simple scripts. The reason we have to manually do all these things is because we have to wait until the previous transaction is on chain, and we have to, every time we run this, initialize an address, send funds to it, and then run the whole script. Okay, so let's start by modifying this to actually instead use MockFrost. So let's have a look at how MockFrost works. In MockFrost, you create a session. And the session is basically your unique virtual blockchain. So within this session, you can do whatever. You can create outputs, you can change the slot number, you can add pools and whatnot. And what this allows you is to basically jumpstart your execution of the smart contract into any state that you want. And yeah, once you have jump started in this setting, you can then submit your transactions against the virtual blockchain and confirm that everything works as intended. So we can actually we have a Swagger UI here. So what we can do is we can go here and just manually, for now, create a new session. You get a curl command to execute this. You could also easily run this as a Python code, but here now we have a new session created just for us. And so to interact with this session, we can actually access some details about the session, not too interesting right now. This is just when it was created and last accessed. So what we will now do is we will take this and we will create from it, a new base URL. Basically, we're just saying MockFrost.dev/ let's have a close look. We can just infer this from the API v0, session ID in the front, API v0, that's it. But then we are not supposed to put the v0 for BlockFrost here, so we will just the session ID API v0. Okay, now let's try running the distribute script. Okay, we get a 404. So it's just not initialized yet. So let's have a look. And what we have to do, so what you would otherwise do through the faucet, you can do here. Again, we can do this programmatically. I will just do it for clarity explicitly in this time. We can add a UTXO to our session. So what we would basically do here is we just send a CBOR of the UTXO that we want. That's very convenient if you want to, for example, send a datum, and the datum has to match exactly what you want. Usually this is not an issue to create if you're running programmatically, because basically anytime you're creating a transaction, you implicitly first write the UTXOs and then you create the transaction around it. So yeah, let me quickly generate a CBOR that we want to submit here. Okay, so we're back. I have created a simple script that just takes the name, the key that we want to send our funds to, an amount, and then we generate the transaction output to this address with the specified amount. If you look at how distribute works, it's also, you build a transaction by just adding this output. So basically we're doing the exact same thing, very simple to set up in case for your unit testing. And now let's run this. Okay, we need some parameters. I've run this here, generates the following string. And now we can go and we add a transaction output. Let's go, add it here. Make sure to also send our session ID. And now, very nice, we get back a transaction ID and an output index. This can be very useful for you. For example, if you want to specifically, if you're building some contract, you want to specifically generate some, you want to specifically pick a certain UTXO, but maybe it's not so useful. It depends on your use case. Anyways, what we're doing here is, we've gotten back in TXID and an output index. We don't need it in this case. We just want to make sure that there are funds at the address. All right, and as we can now see, let me scroll this a bit up. We had some trouble submitting the transaction, but finally we now get the transaction ID. Note, we cannot actually use this transaction ID and actually view it in an Explorer. We don't have that, but we can immediately proceed and run further transactions. Let me adjust quickly the corresponding endpoints. We can now immediately run MakeVest. And there we go, we have the transaction generated. So now let's try to collect our funds from as a beneficiary from the contract. So we run collectVest to actually now execute the smart contract, try to withdraw the funds as they should be after the deadline now. When we go and we actually try to execute this, we'll find that the evaluation fails because the deadline has not been reached. And this is because by default, we are at slot 0, which is not late enough for the current time. So we need to actually adjust the current slot. Let's just set it to some very large value, which we say is in the future. And now let's try again to collect our vest. And it worked. So as you can see here, we have simply changed the BlockFrost chain context from using the BlockFrost API. We needed to adjust a bit how the session works, initializing the session, then initializing the funds for some address, and finally manipulating the slots. But we were able to simulate an entire run for this transaction. Now, what's more is once you have set up everything to reproduce deterministically your tests, you can also use the script to check how expensive your contract is. So when you submit the transaction, you will actually also get feedback on returned here by BlockFrost on how expensive the transaction was. Further, if your transaction fails, you will get detailed logs, which is the log printed from your smart contract in the execution trace. So, as you can see, MockFrost is a very powerful tool that you can just drop into your BlockFrost setting. Gives you many knobs to turn to reliably and deterministically simulate transactions. So if this piqued your interest, make sure to check out Plutus Bench, the Plutus Bench repository containing the MockFrost code. And yes, give it a try, either using the official MockFrost server, which I did now, or by running it locally and, for example, create a fixture that serves the server. This, if you need more examples, you can see actually in the test cases of the Plutus benchmark itself. We run the server as a fixture, start it next to the test cases, and then interact directly with the server. You can see more detailed samples on how to automatically interact with the server here as well. There's a client that creates a session, creates a chain context, which can then be used directly. And here are some helpful wrapper classes to fund a user, for example. However, this is not necessary, and you can just use your basic request tool of your choice to interact. Okay. I hope this was a helpful introduction to MockFrost, how to drop it into your code base and replace BlockFrost for your unit tests so that you get full reproducibility for your test cases. If you enjoyed this, leave me a comment on what further features you would want in Plutus Bench and let me know what you think. Thank you.